is Vishrut BG. I am working as an assistant professor in Department of Information Science and Engineering, SJVIT, Bangalore. I welcome you all to this lab session on machine learning.
Hello students. We'll start with the 7th program, which states, write a program to construct a Bayesian network considering medical data. Use this model to demonstrate the diagnosis of heart patients using standard heart diseases data set. You can use Java or Python ML library classes or API. So here they have clearly told us to use a heart related data set, medical data set. So for this I am making use of some of the library functions like NumPy, Pandas, CSV. It's again your comma separated values. Then you have estimator to estimate the values. You have a model from your Bayesian model, okay, and then inference, that is to eliminate some of the unrelated values. Coming to our program, lines is equals to list of csv.reader open data7 underscore names.csv. Okay, here we are taking a data7 underscore names. Okay, so what does your data7 consist of? The data7 underscore names consist of the labels of your different columns available in your data. What all it has? It has age, it has sex, it has CP, okay, then trust BPS, then cholesterol, FBS, stress ECG, and all those different medical terminologies. Okay, that is being printed here. We have totally around 8 to 9 attributes available in this. Okay, so those attributes are being displayed. Once those attributes has been displayed, after that we have heart disease is equals to pd.read underscore csv data7 hyphen heart.csv. So here we are taking two different data sets, one for the name and the other one for the data that has to be placed under the respective names. So those things you can see in the screen. The data is being made available, everything, it is a numerical value, it is 63, 1, 1, 145 and so on. We totally have around, how many data you have? You totally have around 303 data from your data set. Okay, so what I will do, address is equals to so and so. So I make sure those attributes are come under those names. So I will just give it as names is equals to attributes. After that, heart disease equals heart disease dot replace. If you have any of the irrelevant data or maybe misleading data, or it can be any of the negative data, or it can be like noisy data, like if data is not at all available, then I have to put it as, if you have a question mark there, then I have to replace it with NaN, not applicable. The same thing I am doing it here, and I am displaying the values. Okay, once I display the values, the next thing would be to print some of the data, that is few X data heads, data set head. So what does this head do? It will display the first 5 values of your data set. Okay, print heart disease dot head. Okay, you can see here you have only 5 columns, that is 5 rows of your data. Okay, attribute data types, and it will display you the data types of that particular attributes. What are those? Age, it is in the form of integer. Sex, it is in the form of integer. CP, it is in the form of integer. Everything it is in almost in the form of an integer. Old peak being your floating point value, slope being your integer, that is calorie or something in that way, that is an object. It can either be positive, negative, or anything in that way. Then what I have to do? I have to model here Bayesian network. How do I model here a Bayesian network? I'll start using the inbuilt function Bayesian model within braces. I'll start displaying the values. What all values I have to take? I have to take age and then trust BPS. In the same way, age with FBS, then sex, test B, that is FBS, all such things. I'll make sure these attributes are coming for the selection purpose, and then I'll calculate the maximum likelihood estimator. How do I calculate it? By we know that we have a formula for your maximum likelihood estimator. Okay, which I'll fit inside the model by giving it as fit within braces heart disease comma estimator is equals to maximum likelihood estimator. Okay, and then I'll start going with the Bayesian network, which I just give it as interferencing with Bayesian network heart disease underscore interference is equals to variable eliminator, okay, of model. If you have any of your invalid data, I have to erase this. After that, I'll start printing the probability of heart disease given age is equals to 20. How do I check with that? I'll just give it as variable is equals to heart disease, evidence is equals to age. Okay, and then here you can see here it is, I'll just give it in the form of a query about 20, about 28. Okay, in the same way, probability of heart disease given cholesterol is equals to 100. In the same way, I'll fix the value for your cholesterol to be 100. Okay, the same thing will be displayed here. Probability of heart disease given age is equals to 20. Okay, how many people are there under 20, age 20? Okay, that thing is being displayed here. In the same way, probability of heart disease given cholesterol value equals 100. Those data will be displayed here. Clear with that? So what we are doing here, we are making sure that we design a network wherein with the help of a query we try to fix the values, that is we try to extract the values, wherein we'll give the probability conditions, conditional probability table here. Okay, if the age is 20 and if the values of heart related things are so and so, then he is considered to be a heart disease patient. Okay, which we have already discussed in the class about this same example. The same thing, we are running it with the help of a program. Am I clear with that? Fine then. So in the next session, we'll be starting up with the 8th program, which is